So in the part one of looking at logarithms, we looked at just the basic definition of what a log is or a logarithm is. Now let's deal with some basic properties. So one of the really cool things about logarithms, and again, if you keep going in math, you'll see how valuable this all actually is. Um, but either way, I think this is a lot of fun to work through these problems. So let's go over a few basic properties. Here we have if a is greater than 0 and not equal to 1, and m and n are positive numbers, and p can be any real number, then we have the log product rule, log quotient rule, and log power rule. So the log product rule is if you have log base a of m times n, then you can write it as log base a of m plus log base a of n. And similarly, if you have log base a of m over n, or m divided by n, then you can write it as log base a of m minus log base a of n. So that's called the quotient rule. And then another one is the power rule. Okay, this one is particularly helpful. If you have log base a of m to the p, okay, this is equal to p times log base a of m. Okay, so let's see if we can solve some of these problems given these rules. So let's say we have log base 3 of 7 minus log base 3 of 8 is equal to log base 3 of x. We want to solve for x. Well, let's rewrite these two here using these log rules. So we have log base 3 of 7 minus log base 3 of 8. If we look at our different rules, we'll notice that the quotient rule is our one we want to go with. So we can rewrite these as log base 3 of 7 divided by 8. Okay, so here x is going to equal 7 over 8, and we just get that directly from the quotient rule. Okay, how about this one? Here we have log base 8 of 5 plus log base 8 of x is equal to log base 8 of 55. Okay, well, we can rewrite log base 8 of 5 plus log base 8 of x as log base 8 of 5 times x, and this is equal to log base 8 of 55, right? Because of how we have this here, okay? So we have log base 8 of 5x is equal to log base 8 of 55. So we can infer then that 5x is equal to 55. Okay, so we can divide both sides by 5, and we get x is equal to 11. Okay, so we can have, yes, so x should be equal to 11. So log base 8 of 5 plus log base 8 of 11 gives us log base 8 of 55. Okay. So how about this one? We have log base 9 of 4 is equal to x times log base 9 of 2. Okay, so we can rewrite this as log base 9 of 4 is equal to log base 9 of 2 to the x. And again, this comes from our exponent rule, okay? So we have 2 times log base 9, or sorry, x times log base 9 of 2. This looks a lot like our power rule here, where we have m to the p. Log base a of m to the p is equal to p times log base a of m. Okay, so we can write this as log base 9 of 4 equals log base 9 of 2 to the x. So therefore we have 4 is equal to 2 to the x. Okay, so what number for x gives us 2 to the x equals 4? Well, that would be x equals 2. Okay, so now let's see, instead of solving equations, let's see if we can maybe expand and contract different logarithmic expressions given these basic rules. Okay, so let's expand these. We have log of y times x to the third, and we're going to see if we can write this as expanded as possible. Okay, so right away we see we have a product of y and x to the third. So we have y times x to the third. So that means we can write this immediately as log of y plus log of x to the third. And this comes straight from our product rule, okay? Log of m times n is equal to log of m plus log of n, okay? And then we can do one more thing here. So we take this log of x to the third, and we can apply our power rule, okay? So if we have, our power rule states that if we have log of m to the p. This is equal to p times log of m. So we can rewrite this as log of y plus 3 times log of x. Okay. So with all of these, I just want to keep reiterating here. The most valuable thing you can do here is memorize these log rules and then spend some time practicing applying them. Okay, it's just recognizing what kind of changes you can make based on these three basic log rules. If you can memorize those three rules, these really aren't that bad. It's just all about memorizing those rules. Okay, so here we have log of x to the ninth over log of z or over z. So we can expand this as a bit using our quotient rule as a difference of two logs here. So we can write this as log of x to the ninth minus log of z. Okay, that's just straight from the quotient rule. Nothing else crazy is going on here. And then again, straight from the product rule, we can take this first term, log x to the ninth, and write this as 9 times log x. Okay, so this would be our most expanded version here. Okay, how about log y to the sixth times log z? Well, similar to the first one, we can just write this as a sum of two logs. So we have log of y to the sixth plus log of z. And then again, using our power rule, we can have 6 times log of y plus log of z. Okay, well, let's look at this one here. This one's a little bit harder. Here we have log of x to the third, y to the fourth over z. So right away, there's several different ways you can approach this. If you see one of these more complicated problems, if you will, you have lots of different routes you can go with this. You can start by dealing with it as a product, or you can start by dealing with it as a difference or as a quotient. But let's deal with the quotient side of this first. So we can say that this is equal to log of x to the third, y to the fourth minus log of z. Okay, and that comes from the fact that we have this quotient where this is our numerator, this is our denominator. So we can rewrite it as follows. Okay, and then now we have this first term here, log x to the third times log y to the fourth. We can write this as a sum because it's a product here. Okay, so we have log of x to the third plus log of y to the fourth minus log of z. Okay, and then now we can just do our power rule to simplify these first two terms. So we'll get 3 log x plus 4 log y minus log z. So that would be our fully simplified, our fully expanded, I guess unsimplified, our fully expanded logarithm here. Okay. So we can go the other direction with this too. We can write as a single log as well. Okay. So let's say we're given 7 log w minus 1/4 log y plus 6 log x. So the first thing I like to do is I like to try to simplify the equation as much as I can. This one's already simplified pretty well. We're going to see an example here in a minute if it's not. But I like to start by simplifying everything, do any distributions, whatever it is we have to do to make it as simple looking as possible. And then I like to deal with the product rule first, okay? So what I'm going to do is I'm going to undo all of these product rules here. So we have 7 log w. We can rewrite this as log w to the 7th. And then minus 1/4 log y, we can write this as minus log of y to the 1/4. And then 6 log x, we can write this as plus log x to the 6th. And now we can just do our quotient and our product rules here, okay? So if we do these first two terms here, we have log w to the 7 minus log y to the 1/4. So we can just do straight quotient rule, and that's going to give us log of w to the 7th over y to the 1/4 plus log of x to the 6th. So then we're just going to have the product rule here. So we can write this as a single log where w to the 7th over y to the 1/4 is multiplied by x to the 6th. So this would be log of w to the 7th, x to the 6th, over y to the 1 over 4. And that would be our fully simplified single logarithm here. Okay, how about this one? Here we have 4 times, in parentheses here, log y minus 3 log w, close parentheses, plus 3 log z. So here we're going to start by distributing this 4, because like I said, we want to make this equation as simple looking as possible. So if we distribute this 4, we're going to end up with 4 log y minus 4 times 3, so 12 log w, plus 3 log z. And like I said, I like to deal with all of the power rules to start with. So here we're going to deal with this first one here. So this will become log y to the 4th, and we'll have minus log of w to the 12th plus log z to the 3rd. And again, all of those came straight from the the power rule. And now we can just do our typical product and quotient rules. So these first two terms here, we have log y to the 4th minus log w to the 12th. So we can rewrite that as log of y to the 4th over w to the 12th. Then we have our log z to the 3rd. So then from there, we can just do the basic product rule, and that's going to give us log of y to the 4th z to the 3rd over w to the 12th. Okay, and now we have it as a single log, so we're good. Now let's look at 6 times log x minus 2 minus 4 log x plus 6. Okay, so don't let the fact that there is an expression inside of these logs scare you too much. All of the same basic rules are going to apply. So let's go ahead and deal with our power rule first. So we can rewrite this first term as log of x minus 2 to the 6th. And the second one we can write as log of x plus 6 to the 4. And then now we just do basic quotient rule. So this will give us log of, let me get a bigger one here, x minus 2 squared, or sorry, 6th over x plus 6 to the 4th. And that's about as simple as you're going to make it. So this would be your final answer.